Hi guys, welcome to this, my video on measures of spread. Darren here from Maths Guru. Thank you very much for following or watching along, or have you been forced to watch along? That worries me. If you can do me a favor and head over to YouTube and subscribe to my channel. It sounds a bit needy, but really by you clicking that button, you'll get updates of what's coming, but also it lets me know that actually people are watching and that sitting in this room on my own talking to myself actually is having some sort of an impact. More so on TikTok. I know I'm too old for that, aren't I? But there are videos on there and I'm adding new content all of the time. So if you want to head over there as well, that will be great. Now, what are we dealing with today? We're going to understand what the range, the interquartile range, and the standard deviation are when related to measure of spread. You've been dealing with the range since year 7. What is it? It's the highest number, take away the smallest number. Yeah. But what is this interquartile range? What is a standard deviation? These might be new to you. Have your summary book near you. You can go to Maths Guru, download all these notes, copy them all over, or write all over them, and stick them in your maths book. A great resource, if I don't say so myself. We need to know when to be able to use each as a measure of spread for a particular distribution and be able to use the CAS. Now, if you've watched the previous video, I've actually already shown you how to use the CAS to come up with summary statistics, but I'll do it again. Cool, it's not an easy word to say. Now, this is building on quite an important topic, right? And again, as I've said in a previous video, year 12 takes this much, much deeper. So a strong foundation now is really important. We've looked at the measures of center, all right? And which one to use for a particular data set. We're now going to look at spread. And if you remember, spread is variability, all right? How wide the data is in comparison to some sort of center. It's important to look at how spread out the data is, right? Because obviously if it's closer, that's quite good for lots of data things. If it's spread out, that's not particularly great. Right now, as I've said, the range in year 7, what is it? Yes, you already know it's the highest value, take away the lowest value. But is that always the best thing to do? Can you think of any examples where that might actually give you some sort of wrong or a misleading data? Well, that's what this video is going to show you. Now, here's the problem with the range, an outlier. And yes, that little picture is me, all right? When I was younger with my iPod, yes, I didn't have an iPad, I had a Walkman, all right? If you don't know what Walkman is, God, these things are incredible. You put cassettes in. You don't know what cassette is, do you? Why am I even bothering? Anyway, wherever I go, I feel like I'm a bit of a loner. Yes, I'm an outsider. I don't quite fit in. People ask me what I do for a job, and I go, I'm a teacher. They go, oh. And then they go, what do you teach? And I go, kids. And they go, huh? Hilarious. Dad joke. Anyway, and they go, no, what do you teach? And I go, oh, here we go. And I go, maths. And they go, oh. And if they haven't already walked away from me at this point, which is a little embarrassing in a bar when I'm standing there alone, the next thing they're bound to say to me is, well, oh, I couldn't do maths at school. I don't know where I'm going to go with that conversation, particularly. Oh, okay, well, nor could I. And that's where conversation dries up. So maybe I need to come up with a whole new and exciting career. But an outlier is someone who doesn't quite fit in. It is a bit separate from all the rest, right? And in many cases, mathematically, that could be a really large number that doesn't fit in the numbers that I've got, or a really small number, maybe even a negative number when we got lots of positives. Now, the good thing for this course is outliers tend to be fairly obvious, right? So if we look at the numbers, as I've said here, the numbers 1, 2, 3, 4, and 5. Can we find the range of those numbers? Of course we can. The range is going to be the biggest number minus the smallest number. So in that situation, the range is going to be 5 minus 1, which is basically 4. Nice, right? That sort of makes sense. What about if I was actually to replace that 5 with 57? If I now replaced it and become 1, 2, 3, 4, and 57, what I notice is these numbers are fairly closely packed together, right? So that's that nice and they're not very spread out. And then suddenly we throw in this number 57 and life gets ridiculous. Because if I now work out my range, what's my range going to be? Well, my range is going to be 57 minus 1, which is going to be 56. Hold on a moment, that one massive number has blown out my range ridiculously, all right? And suddenly that range doesn't make any sense to me. So we need to keep an eye out for outliers, numbers that seem really big or sort of set far away from the main data set. So let's have a look at an example. Consider the marks for 2 different tasks awarded to a group of students, task A and task B. Now, the good thing about this data, and the question is asking to find the range of each of these distributions, the good thing about the data is it's in numerical order. So we got the smallest number here, which is 2, the highest number, which is 94. Smallest number here is 11, highest number here is 91. So life is really, really good, because I can now say, well then for task A, my range is equal to, what's that, 94 minus 2, which is simply 92, right? So it could be 92 marks. That's pretty wide range if you think about it. Somebody got 2 marks on a test, somebody got 94. Let's look at B. What is my range? Well, that's going to be my biggest data item, which is 91, minus my smallest data, which is 11, which is going to give me 80. So what can I now do here? Well, the whole point of doing calculations and statistics is to compare. The range on its own, if I knew the range of A was 92 on its own, doesn't mean anything. Whoopie-doo. Now I can say, by comparing A and B, that B is less variable. Why? Because it doesn't have as wide a range. The scores seem to be closely packed together, assuming they go from 0 to 100, whereas A seems wider apart. See, I've already got some sort of statistical investigation now. I can talk about my data. But the thing is, are there any obvious outliers in our data? Well, if we look at task B, the numbers seem to go, we've got some 10s, some 20s, some 30s, 40s, 50s, 60s, 70s, 80s and 90s. So the data seems to be spread from the sort of 11 up to 91, and there are some numbers in each of those sort of intervals. Task A, on the other hand, seems to have a bit of a gap. It jumps from 59 all the way up to 94. How many times have you sat in a test and everyone's got really low marks, and there's always those 2 people, normally sitting at the back, who've just managed to smash it, and you're like, how have you done that? All right. Anyway, that could be a possible. So is 91 and 94 an outlier? It wasn't necessarily obvious, was it, from that particular data? But one of the reasons we like drawing stem plots of these data is, what do we notice now? Well, if I actually take task A and put it in a stem plot, whoa, we notice there is this gap. And we notice that maybe 91 and 94 could be outliers. Now later on, again, there's a way of actually defining what outliers are, and you need to use something called the interquartile range. Now if you haven't met it before, don't worry about it. I'm going to explain what it is now. The interquartile range is basically the middle 50% of our data. Now again, remember, if we were to write all these numbers out, I would have had 2, 6, 9, 10, 11, 12, 13, 22, 23, all the way up to 56, 56, 59, oops, let's do 91 and 94, right? So all my data in a long line, 2, 6, 9, 10, would be that way there, yeah? Now, obviously, the problem with the range is it takes our smallest value and our largest value. So there, typically, we had our range was 2 and 94. Take them away, that gave me the 92. But if I want to sort of fudge the mathematics, if I want to go, let's be clever about this, I can look at the middle 50% of my data. I can split my data into half and then halves again. All right, and it's not going to be easy with my data item here, but let's assume halves and halves again. And actually, I can just look at finding the range of the middle 50%. That actually gets rid of the problem of those stupid outliers that could throw my calculations. Because the chances are the middle 50% is going to be roughly around the same amount. Okay, sort of makes sense? So again, if I look at my data as being sort of this massive cake, here is my minimum. Here is my maximum. I can split it into half, and again, think about cakes, and half again, and half again. Whatever this data item is here, and that data item there, the difference between them is going to be roughly where my middle 50% of my data is. That is my interquartile range. Now again, how do we find the interquartile range? Well, it builds on finding the median. And as I just said a moment ago, remember, if we think about a cake, if I had a cake and I've got 3 friends, because I want to bit myself. If I have a cake, then what do I want to do to cut it? Well, the first thing hopefully I do is everyone cuts it in half. No one tries to cut a cake with a quarter. It is impossible to do. Please tell me you don't do that. All right, I'm going to cut my cake in half. And then because I can cut it in half again, I'm going to cut it in half again. And that's actually how to split anything into quarters. Cut it in half and cut it in half again. So I'm going to do that first. I'm going to firstly cut my data in half. What does that mean? Find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 data items. So there are 30 data items here. So I want to add 1 and divide by 2, which is going to give me 15.5. So my middle value is going to fall between the 15th and the 16th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so it's going to fall between my 15th and 16th. So that means I'm going to draw a line here. I've now cut my data in half. What do I need to do again? Well, I now take each of those halves and cut them in half again. Whoa! All right, so again, I'm now going to, let's just rub this a little bit out. So let's rub those out there. Yep. So having split my data in half, I'm now going to do the process again, but just with half my data. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data items. So I'm ignoring that last half. So if I've got 15 data items, I'm going to add 1 and divide by 2. Tells me that my half of that data is going to be the 8th position. So 1, 2, 3, 4, 5, 6, 7, 8. There we go. I'm putting a box around it. My 8th position is the number 22. So I now know that the lowest quartile, that halfway part, and we actually call it the lowest quartile, the lower quartile, LQ, is given by the number 22. What do you reckon we do now? Well, we cut the last half. Now, the good thing is, if the lower half, it was the 8th data item, the upper half, it is also the 8th data item from the start or from the end. So let's look at this again. So we've got 1, 2, 3, 4, 5, 6, 7, and there is my 8th data item. Let's just check it's the same from the end. 1, 2, 3, 4, 5, 6, 7, 8, 7, not 7, 47. So my upper quartile, all right, and again, that's basically the quarter, the half of the top half is basically 47. Having done that, there is a quite simple rule that says to find the interquartile range. Now, range means take the numbers away. We're going to basically say that my IQR, my interquartile range, is my upper quartile minus my lower quartile. So I'm going to do 47 minus 22, which gives me 25. So that tells me that the spread of the middle 50% of my data is 25 marks. Again, on its own, not particularly useful, but if we were to compare that with data or task B, life would be good. All right, so there we go. Let's do that for task B. How many people do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That sort of makes sense because the same people did task A and task B, but I'm always going to check. So we've got n equals 30. So again, where was my middle? Well, add 1, divide by 2 gives me 15.5. So it's between the 15th and 16th data item. Right, I'm not going to actually circle them. I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So halfway between my 15th and 16th term will be there. Now, the good thing is I don't need to work out that value. I don't care. All I need to do is cut the data in half and cut the data in half again. So now let's look at my bottom half. Again, we knew that previously it was the 8th number in. All right, so again, it's going to be the 8th number in. Let's just check because the bottom half again had 15 data items. I'm going to add 1, divide by 2, which gives me 8. So it's the 8th number in. So 1, 2, 3, 4, 5, 6, 7, 8 gives me this value here. So the middle part of the bottom middle, or otherwise known as the lower quartile, is basically 31. What do? We now do the top half. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So my upper quartile, all right, the upper half of the half is given as 73. So my interquartile range, the split between those two quartiles. The middle 50% gives me 73 minus 31, which gives me 42. Now again, let's compare it. My previous one was 25. This one works out to be 42. So what can we tell? We can say that the middle 50% of task B was much, much higher. The scores of those middle 50% were much, much higher than the task A was, which was really, really quite low. And you could have told that by the way that things were distributed. Now, having done that, that's interquartile range, there's something else we need to build on as well. And again, write this in your summary book, really, really useful, all right? Standard deviation. When we do a standard deviation, we can split our data into other things as well. Whereas here, we split them into quarters. Here, we split our data into 6 sections, right? Give or take. Now, when you do your actual VCE, and you're probably going to get sick to death of hearing about this at some point, we actually score it on a bell curve. We actually score it on something called the normal distribution. And this point here is my center value, right? That's the mean of my distribution. And generally speaking, we can find that things do go in this lovely curve. Now, there are then sections either side of the mean, right? Don't worry about the notation for the moment. But this here, where I'm drawing this line now, that is one section. And actually, all of these sections that I'm now highlighting have exactly the same width, both above the center point, or the mean, and below. And as it turns out, the width of one of those things there is called a standard deviation, SD. Wow, what do we use these for? That'll come back a little bit later on, particularly when you see the numbers 99.7, 95, and 68 on there. That becomes massively important in a later video. But the width of those standard deviations is really important, because the wider the standard deviations, the more the spread. The narrower the standard deviations, the less the spread, or the more compressed our data is. How do we work out a standard deviation? Well, if I was being really, really horrible to you, then basically I'd make you do it by hand. And I'm going to show you one example of being able to do it by hand, just so that you know how lucky you are that you're going to be able to do it with your CAS. But normally you would do it on your CAS. But the formula states the standard deviation is equal to the square root of the sum of x minus x bar. We've met x bar before as the mean. So if you remember, x bar is equal to the mean, all squared divided by n minus 1. And again, we've met n before is the number of data items, right? Num of items. So while that looks complicated, we've got a rough idea of what it's, or of how to read it. How do we do it? All right, here we go. So use the following formula to find the standard deviation of the numbers 2, 3, and 4. Rightio. So the first thing we need to do is I actually do a table. Right, I don't know how big my table is going to be, but the first thing I'm going to do is I'm going to write down my values of x. So x stands for my data items. I've got the numbers 2, 3, and 4. Now, what we then do is we're now going to look at my formula, and we're going to do x minus x bar. I'm actually going to break my formula down or do it in reverse. So x minus x bar, what on earth? Oh, my head just disappeared. What does x bar stand for? Oh, it's the mean. So the first thing I'm going to do is got to find the mean of my numbers. So that's 2 plus 3 plus 4 divided by 3, which just so happens to give me 3. Ooh, that was lucky. So now I'm going to add a new column to my table. I'm going to do x minus x bar. So x is 2 minus x bar is 3. So 2 minus 3 is minus 1. 3 minus 3 is 0. 4 minus 3 is 1. Now, what does it tell me to do next? All right, so it basically wants me to square all those values. So now I need to do x minus x bar squared. All right, so I'll add another column. So it becomes x minus x bar squared. So I'm going to take each of the values in the previous column and square them. All right, so minus 1 squared is 1. 0 squared is 0. 1 squared is 1. Okay, so where's the next part of my formula? Well, if I expand it a bit further, I've got that sum in front of it. So I now want to find the sum of all of the numbers I've just created. All right, so there we go. So there is my sum. If I add all those together, I'm going to get 2. What do I then need to do? I then need to divide by n minus 1. So the number I've just got there, so I've got the number 2. I want to divide it by n minus 1, the number of data items divided by, so the number of data items minus 1. Well, there are 3 data items. We've got the numbers 2, 3, and 4. Take 1 off of that, gives me 2. So I'm going to do 2 divided by 2, which gives me 1. And then I've got to square root it, yeah? So then I have to square root that value. So I'm looking for the square root of 1, which just so happens to be 1. So therefore, my standard deviation for those numbers is 1. That means there is 1 unit. If I was to draw this as a bell curve, he says making this really, really untidy. It's centered around my average. So it's centered around my mean, which was 3. And if I was to split this into sections, each of those sections would have a width of 1 unit. So it'd be 3, 4, 5, 6, 3, 2, 1, and 0. Okay. And again, this becomes massively important later on. Will you have to do this? I don't know. It depends on your examiner, your teacher. I don't know how evil they are feeling. But the point of it is you may be expected to do this, and there should be a lot of marks for it. But you actually can use your CAS to do that. And what I'm going to do is show you how to do that very quickly now. Now again, I'm going to bring up the TI Inspire. The reason being is it's a calculator that I have handy with me at this moment in time. But ClassPad users, you can use your calculator to do very similar functionality. So what I'm going to do actually is I'm going to do a list and spreadsheet. And I'm going to put in my data. Don't forget to put that title in every single time. And I got the 2, got 3 and 4. And again, if you remember from watching a previous video, if I want my summary statistics, I'm going to menu, statistics, statistics calculations, 1 variable statistics. How many lists have I got? 1. I've just told you it's 1. What is my list called? So I have to click down on here and say data, because the calculator doesn't know. You might have columns and columns of data. Click on OK, and once again, there we go. What happens? We got all my information. So what does X bar stand for? 3. Did we find out previously our mean was 3? Absolutely. What are we trying to find? I'm trying to find my standard deviation. Now, you'll notice here that actually there's these 2 strange ones here. Well, for general maths, we always use the one that has SX on it, all right? And yes, I know schoolboys have put an extra letter in there and are giggling to themselves stupidly. Really? All right, but SX happens to be 1. So your calculator has done all that hard work for you and found the standard deviation. But what else is important in terms of summary statistics? Well, if we look at what's now on the screen, the mean. Well, we've got the mean, we found that. Hello mean, where are you? There we go, the mean is 3. Our standard deviation, we can find that from my calculator, it's 1. The median, would there happen to be anything on the screen? Oh look, my median is 3. My interquartile range, how on earth am I going to find my interquartile range? Well, we said for my interquartile range, we said it was my upper quartile minus my lower quartile. Well, that doesn't say upper quartile and lower quartile on this screen, does it? It doesn't say that anywhere. No, but it does actually say this Q3X. That's actually your calculator saying, hey, that's your upper quartile. So my upper quartile actually there would be 4. My lower quartile is this Q1X, which is 2. And so my interquartile range there will be equal to 2. Whoa! What about my range? How can I find my range? Well, I know my minimum value is 2, and I know my maximum value is 4. So I can also, in this situation, say that my range is equal to 4 minus 2, which is also 2. So my interquartile range and the range are exactly the same. Why? Well, range in this situation, I don't have any outliers. I'm quite happy to use that. Job done. So summary statistics, really, really important. All right, so moving on to another example, using the CAS to find summary statistics. It's too complex to use that formula. So again, for large data sets, there's no way I'd be using that formula. We'd be there literally all day. So let's see whether we can put this data in once again and come up with my summary statistics. So I'm going to close this down. I'm going to go, no, I don't want to save it. I'm going to open a new list and spreadsheet. And in this situation, I'm going to write rain, he says. All right, what's the rainfall we got? We've got 48, 57, 52, 57, 58, 49, 49, 50, 59, 67, 60 and 59. Now the first thing is, again, whenever I put data in a calculator, I'm always making sure that I've got the right number of data items. How do I know that? Because that row number is 12, right? There are 12 months, 12 data items. Now I always run up to make sure that I haven't put decimal places in the wrong place, or I haven't made it 3 digits when I should have done. And there we go. So what do I do now? I go menu, statistics, stat calculations, one variable, and OK. What's my data I'm going to deal with? In this situation, it's going to be rain. Click on OK. And again, what have I got here? Well, my summary statistics I can work out. I've got my mean. So my mean rainfall in that situation is 55.42. What other information's here? My standard deviation. My standard deviation is 5.807 millimeters, right? What else have we got here? I've got 12 data items. My minimum is 48. My lower quartile is 49.5. My median is 57. My upper quartile is 59. And my maximum is 67. So if I wanted to in an exam, I'd be able to write all of these things down, or I'd be able to work things out. So again, I could work out my interquartile range by doing 59 minus 49.5. Now, these 5 data items here that I'm highlighting on the screen are also very important for something called a box plot, which we'll be coming to in another part of our course. But as it stands, that is the end of this video. Hopefully you have found it helpful. I know it's a bit of a long one, sorry about that, but there is a lot of stuff here that's really important. If you understand it, you are going to smash general and further maths for the rest of this year. Thanks very much for watching. More videos in the series coming. Hopefully you've enjoyed it. If you have, subscribe to me on YouTube, follow me on TikTok, etc. And hopefully I'll see you in another video. Take care. Stay safe.